Alright, we're going to try this again. Something I rarely do, which is a second take. So many issues with that first video. Cell phone going off, had noise, dropped stuff. It just was not good. I want to welcome you back. For those of you who have frequent visitors to the channel, which there are many. Where have I been? Why haven't I made a video lately? Well, I had a hardware failure, believe it or not, in the new supercomputer here. And so I've been waiting on an RMA, got everything squared away, and so we're back to making videos. And it was such that I could not make videos at all. So we're back. Everything's good. Life is good. And videos will be coming out again very, very, very frequently. So we're going to talk today about asynchronous programming. And I'm not talking about the days of old where we all look back with longing and think about background workers and various things like that. We're going to be actually talking about async and C# and the await keywords and various things like that, running things in sequence and parallel. But what we're going to do here is we're going to go kind of fast through the basics because it's not hard. Async programming in the new C# is not hard at all. The only thing you've got to remember is you've got to remember that you have to put in your method declarations, you have to put the word async, and then you should, at the end of your method declaration, put the word async. This is required, this is not. Async methods can return three types: void, task, and task of type T. T can be anything that you do or this .NET library defines. So you can get really creative with this, and it's really cool. This is what you'll use 90% of the time. The void is something that you'll use in Windows Forms and WPF programming, maybe some MVC too. But other than that, you're not going to use it a lot. It's kind of call and forget, and it goes and does its own thing. An example would be when you click a button on a Windows Form or WPF application, it's going to go off and do something in response to that button click, and you don't really care what. It's not going to send anything back to the button, right? So there we go. All right. So just because you put the word async in the in the method declaration here does not mean that that method is going to be run asynchronously. If you do not use the await keyword when you call it, it will run synchronously. For instance, if I take and I hit Control X and I cut this out, the compiler is going to warn me that I didn't use await, and because I didn't, it's going to run synchronously. So I'm going to undo that and put the await keyword back in there. So how's this going to run? Well, it's going to first, what we expect to see is it's going to start this process asynchronously, which is going to call this function right here. And then it's going to start the void asynchronously function, which we'll see it running void async. And then I have purposely used task.delay 4000 to exacerbate the old thread.sleep. We use task.delay now. Why? I don't know. It's cool. It's neat. It's the new way of doing things. So task.delay, something to add to your vocabulary. And then we would expect to see that we're going to see running the async. But since the rest of these calls are using the await keyword, it's going to asynchronously run those. And since I've got a 4-second delay built into them, we should see reach the end of the main function next. And we'll see that these things do their thing. So let's go in here and debug. Let's start without debugging. And let's see if it does, in fact, what we think it should do. Running an async function does not return a value. Well, that's what we said it was going to do. Reach the end of the main function. We said it was going to do that too, didn't we? And then returning a value async function, and the return value is 5, which is exactly what we think we should see. It ran them in order, but it ran them asynchronously because you'll notice right here, reach the end of the main function right here, this line of code was reached before the return value here of 5. Does that make sense to you? Let's think about it again. Let's not get lost. we run this, start void, which says running a void async, which is right here. And then we go return no value async. Running async value does not return a function, or does not return a function, a value. And then this one, it's waiting on it. It's running it asynchronously. It's got a 4-second wait in it, so it's just going to move on to reach the end of the main function. And the return value is 5. So that's it. That's all there is to asynchronous programming in very basic terms. Now, it can get, and this on its own isn't too incredibly helpful, but what we'll be talking about now is the other two ways that you're going to do this. And you say, Dean, that's, on its own, how would I ever use this? Well, the other examples are a lot more fun. Basic async programming is not a lot of fun for me to explain because it's really simple and it doesn't do it. So let's think about two other ways that async programming works: in sequence and parallel. And the way I like to equate these is they are very similar to series and parallel in their electrical counterparts. We'll start with in sequence. We'll go here, and basically what we've got is we've got the same thing happening where we fire off a single method that starts a whole bunch of other asynchronous methods, and it reports that method 1, 2, and 3 have finished, and then the sum of their responses, because they're all returning integers, we expect 6 to be the total when it's done, and then it tells us what the sum of those responses are, and it tells us when it's back in the main. So what we expect to happen really is for it to come in here and say it starts the asynchronous and then go through and do its thing, and we'll see the back in the main method. And let's see for ourselves what happens here. Oh, you know what I didn't do? Come on, Dean, get with it. Been a little while. Set as a startup project. There we go. So you'll notice we started an async and then we're right back in the main, right? And the reason is because we've got these task.delays. What's different now is that the task.delays happen before the console.writeLines. If you'll remember in our first example, the console.writeLines happen first, and then the delays. Now we've kind of reversed the tables here, and the sleep is happening. Remember, I went back to old school there. The sleep is happening before the functions are outputting anything to the console. So what we see is that we make a call down here. It puts this up on the console, but then all of the rest of this stuff is waiting on that initial 3-second runoff. So it just goes zipping through here. Everything is happening asynchronously, and comes back in the main function, which is what we see here, and then we see method 1, method 2, and method 3. Now this may not seem logical because you're saying, Dean, if this truly is asynchronous, then shouldn't method 3 finish first because it's got the slowest runoff, and then method 2, and then method 1? Shouldn't that be the order in which things happen? And the answer is not in sequence programming, because what's going to happen is the way we've done this, the way it's put together, is it's going to go in order and wait for each one of these responses to come back. Now they're happening asynchronously, so your main GUI thread is rocking and rolling through here and goes right back up here. It's not waiting. Now another thing you get for free that you didn't used to get in the old one is the response, this method 1 async, when it returns the number 1. When it returns the number 1 and it's here at the end, this is marshaled up through the GUI thread. So you could technically interact with your GUI here, right? If we think about the old background worker methodology, we would have to do a report progress or a run worker completed. But here we can do whatever we want to do, and that is tremendous, people. That is amazing. So that is awaiting in sequence. So hopefully there's no questions with that, because this one's really simple. Just 1, 2, 3, done. The one that's really fun and the one that I really enjoy, we're going to set a startup project, Dean, is the one, and I'm not going to show you the code yet, I'm going to make you wait. I'm going to run it actually. Now I'm going to show you the code because we change it quite a bit, because I make it more like a race, a foot race with these methods. This one is where you can look at it logically and say, okay, these things should finish in a certain order, right? If you look at them, method 3 should finish first, method 2 should finish second, and method 1 should finish third. All right? That is true in parallel asynchronous programming. The difference is you have to remember and you have to group them into a collection. And what you do is you put in together a list of these methods here into a little syntactical sugar. Tasks variable is a new list of tasks that return string. They all have to return the same kind of value, and these all return strings. And you're going to call them method 1, method 2, method 3. Now, what is really interesting here is you need to remember this, the when all, and then there's another one, when any. And let's think about what that means. Is the when all is not going to do anything until every one of the 3 methods have finished. So the when all execution time is going to be what? It's going to be 2,750. Because method 1 is going to finish, method 2 is going to finish, method 3 is going to finish before it moves on and does this. Now, this is some link. I hope I didn't lose anybody. But all I did was, and what I get asked a lot is, if I have an array of strings, should I use a for each loop to put them on the screen? And this is a way that you don't have to. This is a really efficient way to get a list or an array of strings onto the screen in one string. And I'm using a comma as a delimiter. Okay? So this is going to run, and it's going to say that method racer 1, which is method 1, finished, racer 2 finished, racer 3. So what we expect to see here is what? Racer 3 finished, racer 2 finished, racer 1 finished, because they are by time. We expect to see them because they run in parallel. They truly do run in parallel here because we put them in a collection. And then we fire off the task.whenAll, and we pass it the collection. Easy stuff. Easy, easy stuff. And then we're going to experiment with the wait any. And what the wait any does is the wait any, anytime one of these finishes, the first one being at 250 milliseconds, it's going to do something. So we're going to say, while it has tasks in it, we have 3 tasks, do something. And in this case, we're going to remove the response after it finishes, and we're going to write the result. Make sense? It should, because the methods return strings. We're going to put them in a wait any response here. And we're going to say anytime one of these methods finish, stick its result in here, and then remove it from the collection and put on the screen the result. So what we would expect to see here is single result returned, runner 3 finished, runner 2 finished, runner 1 finished, and then this, there won't be any left. They're all gone because we've removed them. Right? Okay, so let's run it and see what happens. And it's exactly what we expected. We get one long string, and this contains all of the results. And then we're going to run the wait any, and you can see that we're outputting each one as a finish. And in this case, racer 3 being the shortest because it was 250 milliseconds. Racer 2 is the next shortest, so it finished second. Racer 1 finished last because it was what? 2,000 milliseconds, so it's the slowest of the 3. So you can start to see the power here to where you can put things together, take them apart, have things happen in order. Parallel async programming is a lot to get your head around, which is why I'm putting this up on SVN, so that you can play with it, blow it up, do whatever you want to do with it. You're going to be read-only, so you can't check in your changes. I've had quite a few users say, hey, if we want to extend it and help you write your source code, can we do that? And I've emailed a couple of you back. I would love to have some great help and some contributors, and we may begin doing that, but for now the CHI and all of that's still going to be read-only. If you are interested in contributing to the code and various other things, then do send me an email. I love it. And while you're down there, go ahead and hit that subscribe button. So that explains the async programming. I wish I could make it sound complicated, but it isn't. They really have, in the new .NET, they've got this thing nailed down. Async programming is it's easy, it's menuable, and what that means is you can do it in sequence if that's what you're comfortable with. You can do it in parallel if you're really an egghead, and you can do everything, even in your own brain in parallel. And you can do just basic async stuff to finish long-running tasks in the background while your GUI is still responsive. So hopefully this video helps. I'm going to stick this code up on the SVN right quick and put the instructions on how to get it. Like I said, while you're down there reading the instructions on how to get it, please do give us a thumbs up. And also hit the subscribe button that you see on the screen now. That helps the channel out a lot. And until next time, have a great day, and we'll see you next time.